Hello, this video will cover Recitation 7 for STT 315. Task 1, Likelihood of a Tax Return Audit. At the beginning of each year, the Internal Revenue Service, IRS, releases information on the likelihood of a tax return being audited. In 2013, the IRS audited 1,242,479 individual tax returns from the total of 145,236,429 filed returns. Also, the IRS audited 25,905 returns from the total of 1,924,887 corporation returns filed. So what I did to just keep things straight is there's information given about individual tax returns and then corporation returns. Task 1A. Suppose an individual tax return is randomly selected. What is the probability that the return was audited by the IRS? Okay, so here we're interested in individual tax return. So the information that we will need will be the number of audited individual tax returns in 2013 and the total number of individual tax returns filed in 13. And to find that probability, we're going to take the number of the audited individual tax returns divided by the total number of individual tax returns filed in 2013. So if I go here, we have 1,242,479 that's how many were audited individual tax returns, and the total was 145,236,429. So we'll just take 1,242,479 and divide that number by the total. And that'll give us 0.00855 or 0.855%. So to get the percentage, you would just multiply by 100, move that decimal place over to the right, and that'll give you that percentage. Task 1B. Determine the probability that an individual return was not audited by the IRS. So here we're still dealing with individual and not corporate. And so the probability that an individual return was not audited, we can use the complement and do 1 minus the probability of those audited. So the probability of if it were audited. So the complement of not audited would be audited. So, and we just found this probability in task A here, because this was the probability that the return was audited, and we're dealing with individual. So we can just do 1 minus 0.00855, and that gives us 0.99145, or if we multiply that by 100 to get the percent, we would get 99.145%. Suppose a corporation tax return is randomly selected. What is the probability that the return was audited by IRS? Okay, so now we're not dealing with individual, we're dealing with corporation tax return. So we'll need to take the number of audited returns divided by the total number of returns for corporate. So if we go back to the information given, so here's the number of audited returns, which is 25,905, and the total of the corporation returns filed is 1,924,887. So we'll take this number and divide it by this number, which I do here, and that gives us 0.01347 or 1.347%. Part D, determine the probability that a corporation return was not audited by IRS. So here we're going to do the same type of thing where we just found the answer of the probability that it was audited for corporation. So we can use the complement. So since we're looking for the probability that it was not audited, we can take 1 minus the probability that that it was audited. So we had found that number to be 0.01347. So if we do 1 minus 0.01347, we get 0.98653 or 98.653%. Task 2. Study of why EMS workers leave the job. An investigation into why emergency medical service EMS workers leave the profession was published in the Journal of Allied Health. The researchers surveyed a sample of 244 former EMS workers, of which 127 were fully compensated while on the job, 45 were partially compensated, and 72 had non-compensated volunteer positions. The number of EMS workers who left the job because of retirement were 7 for fully compensated workers, 11 for partially compensated workers, and 10 for non-compensated volunteers. One of the 244 former EMS workers is selected at random. So what I like doing is it helps to color code or make marks by the information that goes together before we look into what will be asked. That way, for example, in a test scenario, you can kind of keep track of the information that the problem is giving you, so you don't get confused or make errors just by misreading the numbers that go with the information. So anyway, so here, yellow, I highlighted in yellow for fully compensated. So we have 127 EMS workers were fully compensated, and 7 were of the fully compensated workers left because of retirement. And then we have 45 were partially compensated, and 11 left for retirement out of those partially compensated workers. And then last but not least, we had 72 non-compensated volunteer positions, and 10 of those left. So anyways, let's look at what we're being asked. So find the probability that the former EMS worker was fully compensated while on the job. And just to refresh our memories, the last sentence was one of the 244 former EMS workers is selected at random. And that's the total number in the sample. So in order to find the probability that the former EMS worker was fully compensated, we'll need to take the number of fully compensated workers and divide that by the total number of workers in the survey. So the total number of workers in the survey is 244. And if we look at the number of fully compensated workers, that's given right here, which is 127. So the answer to part A is 127 divided by 244. Find the probability that the former EMS worker was fully compensated while on the job and left due to retirement. Okay, so to find that probability, we'll need to take the number of fully compensated workers who left due to retirement and divide that by the total number of workers surveyed. So this denominator number 244 will not change. That's the number of workers surveyed. But where were we given this information of the fully compensated workers who left to retirement or left because of retirement? That's given here. So I've highlighted in yellow fully compensated workers, and that's the number who left because of retirement. So we will get 7 over 244. Task 2C, find the probability that the former EMS worker was not fully compensated while on the job. So there are 2 ways to solve this. We can either use the complement, or we could just kind of solve it not using the complement. So let's first look at if we were to use the complement. So the probability that the former EMS worker was not fully compensated equals 1 minus the probability that it was fully compensated. So in part A, we found the probability of fully compensated So that's 127 over 244. So we would just do 1 minus 127 over 244. And so if I'm doing this by hand, you want to have a common denominator when you're subtracting fractions. So 1 is equivalent to 244 divided by 244, and then subtract 127 over 244. So the denominator would stay the same, and then 244 minus 127 is 117. So you get 117 over 244 if you use the complement property. So, which is 1 minus the complement equals the probability. So, or we could solve it just kind of in a straightforward way. So the probability that the former EMS worker was not fully compensated while on the job equals to the number of partially compensated workers and the number of volunteers. So, and then you would divide that by the total number of workers surveyed. So the total number of workers surveyed is 244. And so let's look at the number of partially compensated and the number of volunteers. So the number of partially compensated was 45, and then 72 was the number of volunteer positions. So we'll do 45 plus 72. So if you do 45 plus 72, you get 117, and then over the total of workers surveyed, which is 244. So either method that you use, you should get the same answer, which is 117 over 244. Part D, find the probability that the former EMS worker was either fully compensated while on the job or left due to retirement. So here I'm going to define probability A as the probability of being fully compensated, and probability B being the probability of leaving due to retirement. So here we want the probability where they were fully compensated or left due to retirement. So we're interested in the probability A or B, which is a union. You can think of probability A union B. And here that equals to the probability of A plus the probability of B minus the probability of A and B, or you can think of this as the intersection, which would, the intersection symbol would look like an upside down U. But anyway, so that's how you will solve this. So probability of A, which is the probability of being fully compensated, we found in part A, which is, if I were to go back, 127 over 244. And then plus probability B, which is the probability of leaving due to retirement. And so to find that, we would add up all of these three numbers down here because those were the numbers of EMS workers who left due to retirement. So we would do 7 for fully compensated, plus 11 for partially compensated, plus 10 for non-compensated. So 7 plus 11 plus 10. So that's here, that's probably a B, and we divide that by 244. And then we want to subtract the probability of A and B, or A intersect B, which is the probability of them being compensated and, or of them being fully compensated and leaving due to retirement. And we found that in part B, which is fully compensated and left due to retirement, which is 7 over 244. So, so we take this number, probability of A, plus probability of B, and subtract the intersection of we subtract probability of A intersect B. So when you simplify and solve all the math, you get 148 divided by 244. And the last task is task 3. So here we're dealing with a different problem, and we have a man is dealt 5 cards, one after the other, from an ordinary deck of 52 cards. What is the probability that they are all spades? So the probability that they are all spades will equal to the number of favorable outcomes which in this case would be pulling a spade, eat one after another, and then divide that by the total number of possible outcomes. And so there's 13 spades in a deck, and if you're not too familiar with like suits in a deck, there's 4 suits in each deck, and this is my bad drawing of the different suits, but we have spades, clubs, diamonds, and hearts. And here we're interested in spades. So if I wasn't too familiar with what that there's 13 spades in the deck, I know that there's 52 cards in a deck and there's 4 different suits. So 52 divided by 4 is 13. So that's another way to find that there's, okay, 13 spades in a deck. So here we're going to, so again, we want to know the probability that a man is dealt 5 cards and one after the other, he has a spade. So here, the probability of getting one spade out of a full deck, which is 52 cards, will be 13, which is the number of favorable outcomes. There's 13 spades in a deck, and divided by the total number of cards in a deck, which is 52. And then since he's being dealt one after the other, meaning that he's not replacing the cards and putting that card back in, now there's only 51 cards left, and there's only 12 spades left because one had already been taken out. So this is going to be the second draw. And then for the third draw, now there's only 50 cards left total and 11 spades left in that deck. And then for the fourth draw, we'd have 49 cards left out of the whole deck, and only 10 of those are spades. And then for the fifth draw, we would have 48 total cards out of the deck, and 9 of them are spades. So you would add up all of those together to get the probability that they are all spades when someone is dealt the 5 cards one after another. And that concludes this video. I hope that it helped.